Hello everyone, welcome back to the Applied Physics lecture series. This is Dr. Y. Anantha Lakshmi. In today's lecture series, let us discuss about the photoelectric effect, matter waves and its properties. This photoelectric effect was discovered in the year 1887 by the German physicist Rudolf Hertz. From this effect, we came to know that the electrons are emitted from a metal surface when this metal is exposed to the external radiation, which is in the form of a light wave. Later, this phenomenon was explained by Einstein. According to the Einstein, the incident light is in the form of an individual particles, and he named these particles as photons. And he also said that for a given frequency, each photon carries some amount of energy and whose energy is equal to E is equal to h nu. Next, he said that inside the metal surface, the electron loses more amount of energies to travel from one surface to the another surface. Next, the electron which are emitted from this metal surface carries larger amount of energy. In his model, he proposed that the electrons leave from the surface, carry some energy. That energy is in the form of kinetic energy. It means that the emitted electron carries an amount of kinetic energy. Till now we said E is equal to h nu. That E is the incident radiation and the emitted electron carries some energy. That energy is in the form of a kinetic energy. Next, for a high intensity of light wave causes more emission and more number of kinetic energy. For a same amount of kinetic energy, the electrons are emitted for a high intensity of light. Next, the excess energy is the kinetic energy of the photon electrons. What are photoelectrons? The electrons emitted from a metal surface are called photoelectrons. These emitted electrons carry some amount of energy. That energy is very maximum and that energy is termed as a kinetic energy according to the Einstein. Next, construction of a photoelectric cell. Consider a gas-filled glass tube, an emitter and a collector. The emitter is connected to the negative terminal of the battery and collector is connected to the positive terminal of the battery. Next, this emitter is coated with a photosensitive material and collector is coated with a platinum or nickel. Working of a photoelectric effect. When a beam of light having a sufficient high frequency is incident on a metal surface, then the light will cause electrons to leave the surface. The phenomena of emission of electrons by the metals when they are exposed to the high frequency of light is called a photoelectric effect and the emitted electrons are called photoelectrons. The minimum frequency of light which causes electrons to be emitted from the metal surface is known as threshold frequency. If no electrons are ejected, it means that the frequency of incident light is less than the threshold frequency. Next, energy of photon. According to Einstein, photons of a light wave having a frequency which has energy E is given by E is equal to h nu, where E is the energy of photon in joules. Next, h is the Planck's constant whose value is 6.626 into 10 to the power of minus 34 joules seconds and nu is the frequency of photon. Next, it is the amount of energy carried by single photon. And the amount of energy, this amount of energy is directly proportional to the frequency and is inversely proportional to the wavelength. Properties of photon. A photon does not have any mass, it does not have any charge and are not deflected in the electric field or magnetic field. All quantum numbers are 0 for a photon. In empty space, the photon moves at a speed of light. Next, in the interaction of radiation with matter, radiation behaves as it is made up of particles called photons. The energy and momentum of a photon are related as E is equal to P dot C, where P is the magnitude of the momentum and C is the speed of light. Therefore, photon is called as virtual particles. Einstein photoelectric equation. According to the Einstein, the radiation is considered as a group of particles. And an energy of photon absorbed by an atom is given by hν, and the amount of energy emitted by a photoelectron is given by kinetic energy. And the final equation is given by hν is equal to W0 plus K dot E, where hν is the energy of incident light wave, W0 is the work function, and K dot E is kinetic energy, which is nothing but half mv square, So, the final equation is hν is equal to W0 plus kinetic energy. What is W0? W0 is nothing but hν0. Therefore, the kinetic energy is equal to h of nu minus nu0 is the final equation. Next, what is the significance? What is the significance of frequency? If nu is less than nu0, this is first one is if nu is less than nu0, that is the kinetic energy is negative. What is nu and what is nu0? If the incident frequency is less than nu0 means threshold frequency. If the incident frequency is less than threshold frequency, then what is happening? Kinetic energy is negative and no emission takes place. If nu is equal to nu0, then kinetic energy is 0. That is, if the incident frequency is equal to the threshold frequency, just emission begins at that stage. If nu is greater than nu0, if the incident frequency is greater than the threshold frequency, then the kinetic energy is positive and emission takes place. Okay, at this point, the frequency where the emission takes place, at that point, the frequency is called as threshold frequency. Is it clear? Next, what is the importance of work function? Work function is the amount of energy which is necessary to start photoelectric emission, and it is a property of the material. Different materials have different values of work function. Next, factors affecting photoelectric effect are type of the material, next intensity, frequency, voltage and time delay are the factors affecting the photoelectric effect. Next, applications of photoelectric effect. Photocell is the most important application. It is most commonly found in the solar panels. It works on the principle of light striking the cathode, which produce current. Next, photomultiplier tube makes the use of photoelectric effect and convert light intensity into electrical current. Photoelectric effect also found applications in photocopies, light meters, photodiodes, phototransistors and so on. It also uses in the scintillators. What is a scintillator? Scintillator is a device that emits light when it attracts radiation in the form of a cosmic source. Are the applications of photoelectric effect. Next, coming to matter waves. Matter waves, after struggling over hundreds of years, the issue of light is a particle or a wave is finally settled and compromised in the early 20th century, that it is accepted that light is a particle as well as a wave. It is a hybrid called wave particle. Light imitates material particles and becomes a vehicle. But there are many microscopic particles such as electrons, neutrons, protons and so on. But which type of particle is behaving like a wave is still under research. Then Later, the idea of matter particles like a wave, that is the photon behaving like a wave, was unknown till 1924. Later, in the year 1924, up to 1924, we don't know whether the photon or an electron or any subatomic particles behaving like a wave. Okay. Next, in the year 1924, de Broglie has submitted a thesis, his PhD thesis. His PhD thesis has given a message in which it consisting of that, a new message in which it consisting of that the material particles such as electrons should have both wave and a particle properties just like photons. De Broglie in the year 1924 has submitted a thesis. His thesis stated a new phenomena that the material particle like electron behaves like both wave and as a particle like photon. And what is the significance? With this new discovery of de Broglie opened a gateway to the development of wave phenomena and a quantum mechanics in the early 19th century. Now, wave particle duality of light. From his theory, from whose theory? From de Broglie theory. It was the evidence that the electron behave like a wave and as well as a particle. It means that the photons are the particles emitted from the light. These also having both duality nature, that is wave and as well as the particle. The evidence for wave nature of light is diffraction and interference phenomena, and the evidence for particle nature of light is photoelectric effect and Compton effect. Photoelectric effect is one of the phenomena which we have covered in our this present video lecture series itself. From the photoelectric effect, we conclude that the electrons emitted from the metal surface are in the form of the particles. So, that is the one evidence of particle nature of light. Next, matter waves. The wave associated with a particle is called a matter wave. In the year 1923, de Broglie postulated that ordinary matter wave like properties, matter wave have some properties like wavelength, which is related to the momentum. That is, de Broglie has given a relation for a wavelength, that is lambda is equal to h by p, where lambda is called de Broglie wavelength and h is called Planck's constant and p is the momentum, where momentum is the product of mass and its velocity. Properties of matter wave. According to the de Broglie, the wavelength of matter was given by lambda is equal to h by p, that is equal to h by mv. As mass increases, its wavelength tends to 0 for macroscopic bodies and it is insignificant. Thus, the wavelength is insignificant for macroscopic particles, and this wavelength is significant. Which wavelength? De Broglie's wavelength is significant for microscopic particles. Matter waves are produced by the motion of particles and are independent of charge. Therefore, they are neither electromagnetic nor acoustic waves, but are new kind of waves. Matter waves are new kind of waves. They can travel through vacuum and do not require any material medium for their propagation. Next, smaller the velocity of the particle, longer is the wavelength of matter wave associated with it. And the velocity of matter waves depends on the velocity of material particles and is not constant for any quantity. The velocity of matter wave is greater than the velocity of light. We have an experimental observation for this point. The velocity of matter wave is greater than the velocity of light. They exhibit diffraction phenomena as any other waves. They exhibit diffraction phenomena. In today's session, we have discussed about what is photoelectric effect, when it is discovered, next what is how it is constructed, working of the photoelectric effect, its importance and the applications of photoelectric effect. Next, what is the importance of matter wave? What is the significance? Which phenomena lead to matter wave? And matter wave is having matter wave is like what? Matter wave has given the evidence of duality nature of light, that is wave and particle duality, and this was explained by de Broglie. And next we have come across the importance of matter wave and different properties of matter wave in today's session. In our next session, let us discuss about photocurrent of photoelectric effect with difference of stopping potentials. And next, experimental observations of photoelectric effect, which leads and explains about the velocity of matter wave is greater than the velocity of light. And the evidence of matter wave, we have one another experiment is Davison-Germer experiment. These are the concepts we are going to discuss in our next session. Thank you.